So today we're going to be doing absorbing Markov chains, total probabilities and recursion. We thought we'd do it with a little bit of fun, with a bit of Dungeons and Dragons if you like. So we have this diagram here where all of the arrows and the numbers indicate the probabilities. And we have to work out, we have a brave knight here who obviously wants to save the princess and doesn't want to get eaten by the dragon. And we have to work out the probability that he rescues the princess under various scenarios. For example, if he starts at the volcano or if he starts at the forest. Okay, so basically just having a look at this diagram, the absorbing state clearly is the dragon here, because the probability that he remains in this state is 1. He basically gets eaten by the dragon if he comes here, the knight in shining armour. And the other absorbing state is that he rescues the princess from her prison, and once he's rescued her, they live happily ever after. So the probability is 1 that he remains in this state. The two states which are transient states, the first one is the volcano, and we can see that if he's in the volcano, he has a third of a probability of being eaten by the dragon. He has a third of a probability of wandering into the forest, and he has a third of a probability of directly getting and finding the princess. And here in the forest, if he's in the forest, he has a 2/3 probability of finding his way out and rescuing the princess, and he has a third probability of finding himself stuck in the volcano. And what we have to do is work these probabilities out. Okay, so that's basically the fun part, although hopefully the rest of it is fun as well. So let's try and I don't think we can fit this on, can we? No, we can't. Okay, so basically let's have a look at the states. So we have the state D, which is the dragon. We have the state V, which is the volcano. We have the state F, which is the forest. And we have the state P, which is the princess. And let's draw them in. So basically once he's been eaten by the dragon, he's been eaten by the dragon. Once he's been got to the princess, he's saved and they live happily ever after. So this is an absorbing state. And this is also an absorbing state, and the other two, V and F, are transient states. Let's just stick these in. So there was a third probability there, a third going from volcano to forest, a third going straight from volcano to the princess, a third going from the forest to the volcano, and 2/3 going from the forest to the princess. Okay, and basically what we're going to do is we're going to make a few definitions here. So let's call xi the state that he is in after I steps. So state x0, and actually that's the only one we're going to be interested in this video. By the way, there is another video after this, but in this particular video, x0 will just be basically where he starts, what state he starts in. Okay, and we need to also make some more definitions here. So we're going to define, okay, AD is equal to the probability of absorption into absorption into my bad. Absorption into P, because we're looking at the chances of him rescuing the princess. Okay, so basically AD is the probability of absorption into P, i.e. rescuing the princess, given that x0, i.e. he starts inside the dragon's stomach. Okay, well we know that clearly AD we know is 0. If he's already in the dragon's stomach, well then he's got absolutely no chance of rescuing the princess, so that's nice and easy. What about the second one? So AV, that is the probability of absorption into P, i.e. rescuing the princess, given that he starts at the volcano, and that basically is question A that we've got to find. We're going to define F as the probability of absorption into P, i.e. rescuing the princess, given that x0 equals F, and that is the second one of our questions. And then finally, AP is the probability of absorption into P, i.e. saving the princess, given that he is already with the princess. Well, clearly that one, AP equals 1. If he's already with the princess, then he has already saved her, so we don't need to we don't need to bother about that. So now what we want to do, let's have a look. We're going to use recursion here. So I'll try and keep it on the same page. It's going to be a little bit difficult. Okay, let's try and get the formula anyway. All right, so basically, let's have a look. What is AV? Well, basically, AV is the probability of rescuing the princess given that he starts at the volcano. And we're going to use recursion. Well, if he starts at the volcano, we know that he's either got a third probability of going straight into the dragon, a third probability of rescuing the princess, and a third of going into F. So basically, AV equals a third AD. So it's a third probability that whatever the AD was, which we actually know is 0, but we'll get back to that in a minute, add a third probability of him going into the forest, which is AF, add a third probability of him directly rescuing the princess. And we'll put these in a minute, but let's just do the other one. So AF here is the probability of saving the princess given that he's in the forest. Well, again, what we need to do here, look, if we got a third, he goes back to the volcano, and 2/3 he rescues the princess. So AF equals 2/3 that he rescues the princess, add 1/3 that he goes into the volcano, and they're recursion, so that's the probability here that he rescues her if he is in the volcano. Now we know that AD is 0 and we know that AP is 1, so we can put those two in. So we have here that AV equals 1, well, AD is 0, so that one gets put out, so that's 1/3 AF add, and we know AP is 1, add a third. And we know that AF equals from here. We know that AF, well, we know that AP is 1, so that equals 2/3, add 1/3 AV. Okay, so now we have two simultaneous equations here, 1 and 2. So let's just solve those. So we get AF equals 2/3, add a third AV. So that's basically, and we can replace AV here by a third AF add a third, i.e. AF equals 2/3 add AF over 9 add a ninth, i.e. 8 AF equals 7. So AF equals 7/8 and AV equals 5/8. Okay, so basically what this means, remember what our definition was. The probability, let's just go back to our definition. So the probability, AF and AV, these two, the probability of absorption into P, i.e. saving the princess, given that they start in the volcano or the forest, and that is exactly this question here. What is the probability that he rescues the princess if he starts at the volcano and if he starts at the forest? Okay, so that's basically AV and AF. So if he starts at the volcano, the probability that he saves the princess is 5/8, and if he starts at the forest, the probability that he saves the princess is 7/8. So that's good, not bad. He wants to start at the forest. Okay, so basically now let's just have a check, because clearly if this is the probability of him saving the princess starting in either the forest or the volcano, presumably the probability that he gets eaten by the dragon, given that he starts in the forest or volcano, must be 1 minus that and 1 minus that. Well, let's just check. So let us define BD as the probability of absorption into D, given that x0 is D. So that's the probability to get absorbed into D, given that he's already in D. Well, clearly that's basically the probability he gets eaten by the dragon, given that he's already been eaten by the dragon. So BD is clearly equal to 1. BV is the probability of absorption into D, given that x0 is V, i.e. the probability that he gets eaten by the dragon, given that he starts in the volcano. BF is the probability that he gets absorbed into D, i.e. eaten by the dragon, given that x0 equals F. And BP is the probability that he gets absorbed into D, i.e. eaten by the dragon, given that x0 is P, i.e. he's already saved the princess. Well, if you'd already saved the princess, we know that BP equals 0. Now, by exactly the same process that we used to get these two equations here, okay, well, let's try and put the equations here. We got that BV equals 1/3 BD add 1/3 BF add 1/3 BP, exactly the same equations, and BF equals 2/3 BP add 1/3 BV, exactly the same. But now we can put these two things in. BD is 1 and BP is 0, so we get that BV now equals 1/3 add, because we know that BD, i.e. the probability of him being eaten by the dragon if he's already been eaten by the dragon, is 1, add 1/3 BF, and BP, the probability of him being eaten by the dragon if he's already saved the princess, is 0, and then BF is basically 2/3, well, BP is 0, we know that's 1/3 BV. Solving these two simultaneous equations, we get BF equals 1/3 add 1/3 BF, i.e. 9BF equals 1 add BF. So BF equals 1/8 and BV equals 3/8, just solving those two equations. Okay, so basically BF is the probability of him being eaten by the dragon given that he starts in the forest is 1/8, and we've already worked out AF is the probability of him saving the princess given that he starts in the forest, and we note that 7/8 plus 1/8 is 1, and ditto AV was the probability of him saving the princess given that he started at the volcano was 5/8, so BV, which is the probability of him being eaten by the dragon given that he starts at the volcano, is 3/8. They must add up to 1. Okay, so now all we need to do is the final two questions, which are, let's have a look. He's randomly transported into either volcano or forest with equal probability, or he's randomly transported into either dragon's lair, volcano, forest, or princess's prison, or jail, or whatever, with equal probability. Okay, so all we need to do now is for the first one, randomly transported. Let's have a look. So this is question 3. So basically, if he's randomly transported, i.e. x0 is 50-50 chance of being either the forest or the volcano, then basically all we need to do is the probability that he rescues the princess, or i.e. absorbed into P, the probability that he rescues the princess or is absorbed into P equals 1/2 AF, because that was a 50% probability that he started in the forest, add 1/2 AV, which equals 1/2 times 7/8, add 1/2 times 5/8. We just work those two out, which equals 3/4. And so therefore the probability that he rescues the princess or is absorbed into P, given that he has a 50-50 chance of being transported Star Trek style into either the forest or the volcano, is 3/4. And therefore the probability that he gets eaten is 1/2 BF add 1/2 BV, which must, the sum of this and he's either going to get eaten or he's not going to get eaten, he's either going to save the princess or he's going to get eaten, is basically 1/2 times 1/8, this is a BF, add 1/2 times 3/8, which is BV, which equals 1/4. So clearly, no matter what we do with the probabilities, he is either going to be rescuing the princess or being eaten by the dragon, and that's correct. So that's number 3. And finally, we have the fourth one, where x0 is a 25% chance that he gets transported either directly into the dragon's mouth, straight into the princess's arms, or in the forest or the volcano. And so basically there, the probability that he rescues the princess, or i.e. absorbed into P, is equal to 1/4 times AD add 1/4 times AF add 1/4 times AV add 1/4 times AP, which equals 1/4 times 0, because the probability he rescues the princess if he's already beaten by the dragon, remember, is 0, add 1/4 times 7/8, add 1/4 times 5/8, add a quarter times 1, AP of course being 1 because he's already rescued the princess, and that equals 5/8, and so therefore the answer to question D is 5/8. This one he's randomly transported into any with equal probability. And just to cross check that, let's just work out the probability that he is eaten by dragon or absorbed into D is basically a quarter BD add a quarter BF add a quarter BV add a quarter BP. And basically that is, well, basically BD, well, the probability that he gets eaten by the dragon if he's already been eaten is 1. Add a quarter times, what were the BF and, where are they? Oh yeah, 1/8 and 3/8. So that's a quarter times 1/8, add a quarter times 3/8, add a quarter times 0, because he's already rescued the princess, BP, and that equals 3/8, which again, they must add up to 1. He will either get absorbed into P or D, one or the other eventually, so that's basically works. Now, okay, well, I hope you found this fun and useful. In the next video, we're going to continue with exactly the same question without the princess, the dragons and the knights, but we're going to be doing this using matrices, and it's much more powerful and frankly much more interesting, although you don't get the pretty pictures. Okay, well, if you've enjoyed this, please press the little thumbs up button and subscribe to the Gresti Academy YouTube channel. Thank you.